Okay, so we're well now into profile or tolerances of profile. You've seen sort of the nature of the profile symbol in that it allows you to define a tolerance zone that isn't just straight lines, parallel planes, concentric circles, where just about any contour can be controlled in terms of its tolerance by tracing along that contour and just offsetting the tolerance zone by however much we're allowed. You also saw that it allows us to shift that tolerance zone and distribute it one way or the other or halfway in between. And they don't use the term distribute, they use the term dispose. So that dispose sort of it comes from the word disposition. So you can see that it's a very flexible tool, and it allows us to cover a lot of ground without a lot of extra definition for the tolerance zone. The important things to remember though is that profile that you're going to draw a tolerance zone around has to be defined with basic dimensions. We have those two ways of doing it. One, we can draw the box around the individual dimensions, and that box tells you immediately that dimension is not going to have a tolerance associated with it. The tolerance zone is going to be defined somewhere else in the feature control frame usually. And that works pretty well. For one thing, it's a good visual indicator that you're dealing with GD&T. Unfortunately, even the modestly complex parts require a lot of dimensions, and all of a sudden all those boxes and that, it just sort of makes for a messy and hard to read drawing. So in this next example that I've tried to reproduce here, this is figure 8.5 in your book or in your handout. Here you're going to see the other approach that you can take, and it works as well as any, I think. It isn't quite as obvious which dimensions are tolerance and which ones aren't, but you can, when you run into the scenario here, and if you look at the actual example, and I didn't put all the dimensions on this sketch, but if you look in the example, you see all the dimensions that are defining size and location. And all of those dimensions have no tolerance attached to them, so they are going to be interpreted as basic based on this note that you would see on the drawing, or very often you'll actually see this note in the tolerance block of the title block. It will say untolerance dimensions are basic. So you can waive the requirement to draw the basic dimension box around each dimension by putting a general note somewhere on the drawing and telling the people that dimensions with no tolerance, you don't go to the default tolerance block, you go to the feature control frame. Okay, so there's that, and again it makes for just a little bit easier to read drawing. And again, as I mentioned in the previous example, there's a lot of dimensioning that's required for even defining something as simple as this shoe-looking shape. A lot of radiuses, a lot of location dimensions, transition points, all those have to be defined, and they're defined as basic. And that means that I am defining to you a perfect geometry around which you're going to define a tolerance zone. And the tolerance zone is simply going to follow that contour as best as it can. Now, I do want you to think a little bit about what that means, is that when I draw that tolerance zone around this contour, obviously, as I follow this line, I just offset that line by however much this thing is allowed, 0.6, and of course there's an equivalent tolerance zone on the inside. So this distance is 0.6, intended to be 0.6 millimeters, I'm sure, and it's equally disposed. It's 3 to the plus, 3 to the minus, because we don't have that U in the circle, the unequally disposed symbol. Again, kind of a cumbersome term. So we know that the tolerance zone that we're defining is this wide, and it's half-half from the basic geometry. But look at what this tolerance zone is, and there's something interesting about this, is that yes, this line is just offset outward and inward by 0.3 in each direction, but look at these radiuses. Here, this radius in the example is defined as a R15. That's the radius that defines the size of the actual feature. But if you look at the tolerance zone, that radius has got to have the same center point as the previous radius. That would define its location, but it has a radius that is equal to this minus that distance, which is 0.3. So it is 14.7 radius. And this one would become 15.3. So the actual size of the tolerance zone changes with the position of the tolerance zone. So it seems obvious, but you do have to think about it when you're trying to set up and measure something like this, is that you are not taking a 15 millimeter radius and offsetting it 0.3 millimeters and still have that radius be 15 millimeters. It is 15 millimeters minus the distance that the tolerance zone is offset. Okay, so that's one little gotcha. We do have the sort of default note, and again, that's something you've got to read the notes. It's something I tell my engineers, I tell my blueprint reading class. The notes are very important. They're often overlooked, but if that's in the note, that's telling you something very important. Okay, so we have that. We have the tolerance zone, and of course the tolerance zone is following along the entire profile, inside and out. Okay, so that's nothing different about that than what we've already talked about. What I do want you to look at, though, is if you look at the feature control frame itself, you'll see that there is an extra little symbol, not in the feature control frame, but actually in the crook of the leader arrow. The leader arrow is always going to be bent like that. It's always going to point to a surface. And if you see this little circle here, that is telling you something incredibly important, and it could have a major impact on how you inspect something or how much it costs to inspect something. That little arrow means all around. So that means that whatever definition of the tolerance zone we have, that follows completely around the outer profile of the part. So that's a big deal. That's a lot more surface than just wherever this happens to be touching. We're not controlling just that individual feature. We're controlling the entire contour all the way around the part, sort of like a candy-coated shell, inside and out. Now, we'll skip up a little bit here, and if you look at figure 8.8, you'll see that we can do something even more powerful and even more expensive, and that is if we put a double arrow in here with the addition of another circle. If we have a double circle there, that means that profile tolerance applies all over. So there's a difference between all around and all over. And I like to think of that all over notion as taking a part and dipping it in paint. You know, the entire surface is going to get coated, and that means then that the tolerance zone in the original example, without the extra circle, just applies around the part. And these two faces, these two side faces that define the thickness of the part, are part of that tolerance zone. And accordingly, if you look at the definition of that thickness, 10 millimeters plus or minus 0.04, it is not a basic dimension. We don't have the tolerance zone that envelops this side, so that dimension is controlled separately. That has a significant impact, again, on how you inspect and what you inspect when you look at this requirement. Now again, I'm not a big fan of little symbols that are hard to even notice and have them have a big impact on how you interpret the GD&T. But in this case, this is what they use, and the double circle then turns this dimension into a basic dimension, and it puts that profile around here also. You know, look at it. If we do this all over requirement, and it encompasses the sides as well, that tolerance zone is the only thing defining all the aspects of that part. So in the case of the all over, instead of the all around, all over tolerance zone, the thickness of this block is now not controlled by a specific tolerance, but it is controlled within the confines of that tolerance zone. So the profile tolerance zone, again, is capable of controlling all aspects of the geometry. It can control the size, it can control the orientation of this surface, so that surface can be tipped that way, or tipped this way, or the surface can look like this. So it controls the form, the orientation, the sizing, everything. So it is a powerful, powerful tool, and if you don't want it to control all those aspects, you have to pull, say, the form out. You may say that these surfaces could be controlled by a separate form control, separate feature control frame, and say that they can do whatever they want within this larger tolerance zone, but we want them to be flat. So we can put a flatness requirement on it first, and then they can tip if they want, or tip this way. But flatness first. So if that's a concern, you do have to separate those aspects from the profile tolerance. Like I said, it's a sort of an easy, lazy way to put a requirement on a part, but a lot can happen in that tolerance zone. All right, so this is just an interesting little aspect of putting tolerance zones all over. Now, you can run into instances where you run into areas that are the tolerance zone can sort of conflict with each other when you start running around corners. We're going to see a couple examples later where that happens. Don't worry about it right now, but it's always a good idea when these tolerances are applied is that you actually draw that tolerance zone and see what the corners, where you make a transition from here to here, what that corner looks like. It could be a very small feature, maybe it could be an inaccessible tolerance area. You just don't know until you actually see it, because this is all you're going to see on the drawing. If you don't at least envision, if not draw, that tolerance zone, you really don't know what it looks like. Okay, so that said, I don't know that I've ever seen that approach used very much, and I think because it can lead to some problems. Okay, so one thing I have seen though is areas where you have variability in the tolerance zone from one point to the other, and that's defined here, or shown here in figure 8.6. Here we have a very relatively simple part, and there are a number of points identification points A, B, C, and D, which are transition points from one feature to the next, from one radius to a tangent point, or a transition point to a straight surface. And what this illustration is here to do is show you that you can define from one point to the next a tolerance zone, and then from that point to the next point you can define another tolerance zone. So let's kind of see what that would look like if we actually did that. So here, looking at from A to B, and this notation is what you will see. This double-headed arrow means between. I think that's in your symbol table. So they're saying that this feature control frame applies from between point A and B, and we have a 0.12 tolerance zone between those points. Okay, and then moving on from B, between B and C, we have a smaller tolerance zone. And then between C and D, which I didn't put there, C and D, we have yet an even smaller tolerance zone. So we have sort of a progressively smaller tolerance zone between those points. You know, a number of reasons why you might do that. It could be a plating, a paint surface, something like that, where for one reason or the other the surface may change in its thickness, and you allow variability in that change. The thing to watch here is not the fact that these tolerance zones are changing, but if you look at that transition point, you have a tolerance zone coming around here that is so big, and then all of a sudden, right at point B, you have a tolerance zone that's taken off and it's smaller. What you have here then is an immediate step downward in the size of the tolerance zone. This is what we call a discontinuity, where at a point with no distance, all of a sudden you change from one size to the next. Sometimes it's not always that easy to determine exactly where point B is. So this is often a problem. It could lead to like a step, a physical step that you could feel with your fingers on that surface. Later on in the next video here, we'll talk about ways we can deal with that. We can actually put a general note that says these areas are supposed to be blended in somehow. All kinds of ways to deal with it, but you have to be aware of it. And when you have a change in that size tolerance zone, you always have the potential for a visible or a sensible transition point that we would call a step. So that is just something that you want to be mindful of when you see this changing tolerance zone, and that tolerance zone changes just abruptly at one point. Alright, so I'll terminate this video at this point here. I'm trying to keep these things nice and short so you can digest them a little bit easier. Pretty much it's going to be more of the same here. We're going to see some ways to do fancy tolerance zones and ways to control this aspect of the transition from one tolerance zone to the next. And after that, we're going to get into some very specialized cases, and we're not going to cover it too much, but we'll get into specialized cases where we can control features as a group. This is again a very specialized side of GD&T, and you often see it with profile. It's a very useful way of controlling individual features and then features in a group, and you can control the aspects of an individual feature and the group separately. And I'll explain, in what instance that would be useful. So anyway, nothing magical about this. I think if you read these examples, it'll become pretty clear to you. It's not really hard to envision this, but again, that transition point from one tolerance zone to the other is often problematic.